Hey everyone, today we're going to talk about Digger Derrick operator safety and training. This is a topic that's been had a little bit of controversy, I guess you would say, over the last few years. OSHA's made some changes and that's caused a little bit of confusion. Hopefully we'll clarify all that today. Of course, when we talk about OSHA, new OSHA regulations are now currently in place. They've been in place for quite a while. It says cranes and derricks in construction, section OSHA 1926, 1400. The new rule goes in effect. Of course, it went in effect in 2010. The new rule does affect digger derrick operators. All operators will have to be trained and certified by certified training facilities. This is only a construction standard. The new OSHA regulations also says that there's some exceptions to the rule. Digger derricks used for auger hose for electrical poles, placing and removing the poles, or handling associated materials to be installed or removed from the poles must comply with 29 CFR 1910 269. This provision ensures comparable safety requirements exist for digger derrick performing electrical pole work. When employers with employees qualified for power transmission and distribution are working in accordance with the power transmission and distribution standard, which is located in 1910-269, that employer will be considered in compliance with this final rule requirements for working around power lines. Of course, when we're on our digger derrick, we always want to make sure we wear the proper protective equipment that we're supposed to wear. All personnel on the job site should have on or have available to them once they get to the job site a hard hat, safety glasses, and of course any other equipment that may be required by their safety department. As with any other equipment we work with, we want to make sure we want to read the operator's manual before operating the derrick. The manual provides instructions needed for you to properly and safely operate the derrick itself. Those should be located in the truck themselves or in the mechanic shop. The mechanics usually keep those for reference. Of course, OSHA and ANSI both operators must comply with all manufacturer's instructions and applicable OSHA and ANSI regulations. For example, the 29 CFR 1910 and 1926, and of course the ANSI standard. The operator and ground personnel must know and be familiar with the following: equipment operating procedures, location and proper operation of all the controls. This is not only is this important for a new truck, but if you have a new employee that's never operated an existing truck that you've had for quite a while, this pertains especially to them. Of course, we want to be familiar with the lifting capacities of that particular unit. Want to make sure we do our inspection and field maintenance requirements. Make sure we have the truck has been maintained well, and of course we've done our inspection on the unit. Emergency procedures involved. If something happens with the truck, we need to know what our emergency procedures are. Maybe the shut off for that particular unit. Of course, we want to do a tailgate discussion before we start any kind of operations on the digger derrick. Operator qualifications. It needs to be a person that's been trained in the safe operation of the derrick. They've read, understands, and follow the safety and operating recommendations contained in the manufacturer's manuals that we mentioned earlier. They are familiar with the safety signs attached to the equipment, and of course the employer's work rules and applicable governmental regulations associated with that digger derrick. Some more qualifications: that the operator has to be verified, has to verify the derrick is operating properly and has been inspected and maintained in accordance with the manufacturer's manual. And it also needs to be verified that all safety signs, guards, and other safety features, any safety covers, any other features that are in place and are in proper condition. If it's required, if it's supposed to be on there, then it should be in place. Our chassis daily pre-trip, our pre-operation checklist. We want to check the vehicle fuel, the tires, of course. Make sure they're at proper inflation and they're not damaged. We want to check the wear on those tires as well to make sure that the tires are not worn out. Check vehicle braking system for proper operation, especially with air brakes. If you have air brakes on the truck, which you should have, we want to check vehicle warning lights and check the brake lights as well. Pretty much a standard walk around for commercial vehicles. We're also going to check the turn signals, the horn, the windshield wipers, all vehicle fluids, and we're going to check it for leaks, of course, and we want to make sure that the mirrors are not busted, or make sure that if the mirrors are supposed to be there, that they are there. A lot of times with digger derricks, the mirrors get damaged or busted or knocked off completely. We want to make sure those are in place. That's going to be important when we start driving the digger derrick and trying to maneuver it into tight locations. We're also going to check the fire extinguisher and DOT flare in the triangle kit. Usually these are located, the fire extinguisher is usually located on the side of the truck, and of course the triangle and the flares are usually located in the cab behind the seat, so to speak. Store all the loose materials properly and refer to your chassis manual for any other requirements. Before operating a digger derrick, perform the frequent periodic inspections and lubrications as outlined in your operator's manual. If a problem is found, don't operate the digger derrick until it's resolved. Repairs should be made by a qualified digger derrick technician. Usually a mechanic has to be trained by that particular manufacturer. Say if it's a Terex, they have to be trained by that particular company to be a qualified technician on that derrick. We're going to on our pre-operation. Now we're going to check our outrigger cylinders, mounting alarms. We're going to check our hydraulic pump and filters, make sure there's no leaks. Make sure the hydraulic level is where it needs to be. We're going to check the hydraulic hoses and fittings. Again, we're checking those for leaks and damage. The digger auger storage bracket mechanism and auger roll-up cable needs to be in really good shape. If there's any damage on the cable or the bracket itself, or even on the mechanism, we want to shut the truck down for repairs. We're going to check the lower and top controls and make sure they're functioning properly. We're going to check the lift cylinders, holding valves and mounting pins. These are the lift cylinders we're checking for leaks. Those seals on those cylinders, they're exposed to a lot of pressure, and those seals do sometimes leak. When we lose cylinder pressure like that, we're losing a lot of lifting capacity as well. We're going to check load capacity charts, make sure they're in place. Some of the older trucks, they may be damaged or they may be missing, but those need to be in place. That's kind of what that's what we're going to use to go by to know what we can pick up or what we can't pick up. We're going to check the throttle body, the throttle control. And it's a common misconception. A lot of people want to operate a digger derrick, and they get on the back control and they floor that back pedal. In a lot of cases, putting the pedal down to the floor is not going to speed the operations of the digger derrick up. We're going to check for broken and cracked welds over the entire unit, the turntable. And like I said, we're going to cover the whole unit, but we're going to check for those broken or cracked welds. We're going to check for loose bolts or missing bolts. I'm going to inspect the boom and fiberglass for damage and cleanliness. Boom that's clean will be easier to inspect. Of course, you have one that has a lot of leaks and you don't clean it. It's hard to tell if it's leaking or not. So we're going to make sure those are clean. Lubrication is a must. The manufacturer's manual will tell you where your lubrication points are and how to do that. Electrical systems, we're going to make sure that we don't have any wires that have been damaged or torn apart. That could affect some of the safety features on the Derrick. Operator's manual, want to make sure that it's in place and we are familiar with that. Of course, our jibs and our attachment and pole puller, maybe even a bucket attachment. We want to inspect those as well to make sure they're not damaged. The body day pre-operation that we're going to do, the pre-check on the body. We're going to check the trailer hitch, the panel hitch and electrical connections on that to make sure there's not any damage. A lot of times the rear of the truck and the towing section of the digger derrick has a lot of damage due to the loading and unloading of poles. All vehicle lights and warning lights must be in place. Grab handles and access steps have to be also in place and not damaged. Walk areas clear of obstruction, and we're going to make sure that all materials are properly stored for travel. If you're the driver of the vehicle, you're responsible for the load. Anything is attached on that vehicle. And of course, we need our mud flaps in place because we don't want to sling any kind of mud on any vehicles that might be traveling behind us while we're traveling down the highways. The safety decals, they're located in several different places on the digger derrick. We want to make sure that those are in place and they are legible. I'm going to inspect the derrick, make sure all of our decals are there. These are very important. Missing or damaged decals have to be replaced. You can't just operate the truck with no decals. I'm going to refer to the operator's manual for proper location of these decals. Lubrication requirements. On each derrick there's going to be a chart that will show you, and if you don't find it on the derrick itself, it should be in the owner's manual that shows you where all these lubrication points should be on the truck. The lubrication portion of this should be done by a trained mechanic by that particular unit. Of course, inside the cab of the digger derrick, we'll make sure all occupants have their seat belts. At least it's available, and we'll make sure that they do buckle up. It is the law. Most vehicles now, most digger derricks now that you get are they're equipped with air brakes. So that's a different section for inspection. Of course, we're going to set the chassis parking brake when we're trying to exit the vehicle. Make sure you pull that air brake handle out to set the brake. And we're going to refer to our chassis manual for the location of where that one might be, that handle may be inside the unit. Of course, our digger derrick inspection process can be pretty lengthy. Although we want to check our controls at the platform and lower controls for proper operation. Make sure that they work properly. We don't want to get in the middle of a job and realize that our second stage won't extend out, or maybe it won't retract in. So we're going to check those. Inspect fire protection equipment and attachments if that particular unit is equipped with those. Inspect visual and audible devices, backup alarms, and things of that nature. Check condition, cleanliness, and dryness of the fiberglass components. Your third stage, the fiberglass, we want to make sure that is dry and clean. That's going to be our isolation point on the boom. And if the fiberglass is dirty or if it's wet, that could cause us a problem with the tracking. We're going to visually check for missing loose covers or guards. If like I said earlier in the program, if a guard is supposed to be there, then it needs to be there. We're going to check for missing and illegible operational warning or instructional markings or markers that should be on the truck. Sometimes they get damaged from normal day-to-day use of the unit. We want to make sure those are in place. We're going to visually check the oil level and hydraulic reservoir. We're going to visually inspect for leaks for all through the hydraulic system. Again, if we lose a lot of hydraulic fluid, we lose a lot of pressure, and that does decrease our ability to pick up more weight. Check all areas for evidence of physical damage. Visually check all cylinders for leaks. Check all fasteners for tightness. We're going to check inspection for structural members such as the digger derrick, accessories, outriggers, subframe attachments. We're going to check any cracks, any attachments for cracks and permanent deformation. We're going to check for rotational obstructions. Say we have something tall in the back of the digger derrick. We'll say we have a transformer that's pretty tall. That could cause a problem if we're trying to rotate the boom around. It could strike whatever we have in there. Another co-worker could also cause rotation obstruction. We want to make sure we don't pin anybody against anything in the back of the vehicle while we're trying to rotate the boom. Visual inspection of all electrical wires. And of course we're going to inspect the winch line, hook, and the slings. All the slings and hooks need to be in good condition. We're going to also inspect our auger roll-up cable. This thing, it takes a lot of abuse. It's under a lot of pressure, and of course over time that cable will have wear spots and those cable strands will start to break. So we want to keep an eye on that to make sure that when it needs to be replaced that we do so. Visually inspect a leveling system or leveling brake if your unit is equipped with that. We're going to do a test of all boom functions to make sure that the boom's working and functioning properly before we get out on the job site. And we're going to inspect for damage or missing auger teeth. If we have especially in some digger derricks come equipped with a secondary auger, a smaller size. So we're going to check that one as well. We want to make sure that the auger's in good condition. A lot of times when we auger a hole in the ground to set a pole or what have you, or maybe even set an anchor, sometimes that auger can be damaged during that process. Of course, when we get to the job site with the digger derrick, after we've done all of our inspections, we want to check the job site. We're going to kind of do a survey of the entire job site. We're going to look at the slope and firmness of the ground. We want to keep in mind that these trucks are very heavy. The ground is soft, and when the truck could become stuck, it could delay quite a bit of time trying to get that truck out of the ground to get it unstuck. Of course, we're going to look for ditches, drop-offs, holes, and debris. If we have a grass or shrub that could create a fire hazard, of course, we want to make sure that we don't park on top of those. If the truck does catch on fire, we do have a lot of hydraulic fluid and diesel fuel that could amplify that. Underground utilities, of course, electric, gas, telephone. We're going to be aware of those, if they're located on the job site. And remember to call Mississippi 811. Call before you dig. That is the law. We're also going to check for overhead utility and power lines. I think that goes without saying. And of course, we're going to check for potential boom interferences during that operation. Now that we're on the job site and we've done our survey, we've looked around, we're familiar with what the hazards that's there on the job site as far as the terrain or what have you. We're going to think about the setup. How should we set this truck up? We need to turn our warning lights first of all, and we're going to set our brake and shock the wheels if we're going to exit the vehicle. We're going to set signs, cones, warning lights, and barricades in accordance with OSHA, ANSI, and state and company rules and regulations. When working near power lines, use grounding and or barricades to dictate, and that should be dictated by your particular company. I'm going to engage the PTO, turn on the power, the master switch if equipped. Some units don't have a master switch. They just have a switch that turns on the PTO. In cold weather, run the hydraulic system to warm the oil, and if it's really cold outside, the unit may run sluggish. So we want to turn that hydraulic pump on and let the oil warm up before we start using the unit full time. Always use the Outrigger pads. Like I said earlier, these trucks are very heavy, and we try to set the Outriggers down on soft terrain the truck could turn over. These pads increase the surface area, spreading out the pressure on the ground, so we don't the Outrigger won't sink into the soft dirt or the soft mud. Center the Outrigger on the pad on a firm ground. We don't want to put it on the edge. And check for a clear path to the ground. We want these pads to set flat on the ground. We don't want them in an incline or maybe across an opening. Outriggers must be set on firm, level surface. Full outrigger spread is required to achieve full boom capacities. Reposition the vehicle if necessary to achieve full outrigger spread. If we can use these pads, that makes the vehicle more stable. Operator must be able to view the outrigger while in motion. We don't want to put the outrigger down without looking. We may have somebody around the side of the truck trying to get something out of one of the bin doors, and of course if we're not paying attention, we could set that outrigger down on top of someone's foot. Alert all personnel stand clear and avoid crushing injury to the foot. Tires shall remain on the ground at all times. We don't want to put the outrigger down so far that the tires clear the ground. We're going to use outrigger pads. Anytime we're setting up across a sloping surface, especially on an incline, you'll have to refer to your chart on the Derrick itself. And we're going to extend low side first, making firm contact with block up if necessary. So if you're on an incline, we want to put the outriggers down on the low side first. Always keep the boom Always keep the boom on the uphill side of the vehicle. Try not to rotate around on the low side, because that will decrease your stability, and the vehicle could flip, especially if you have a lot of weight on the end of the boom. A vehicle set up with a sloping surface continued. Back the vehicle into the slope. We're not going to always work off the rear of the vehicle uphill side. Use outrigger pads at all times. The truck is equipped with access steps and grab handles for you to get get on the vehicle. Use access steps and grab handles for safety, safely entering and exiting the body of the Derrick. Only walk on areas designed for that purpose. Keep walk areas clear of obstructions. We don't need any trip hazards while we're trying to get on and off the vehicle. Before lifting loads, look at the load capacity chart located on that Derrick, and make sure that you are not exceeding the load for the desired boom length, elevation, and load radius. Here's just another example of a load chart that was found on a this is one here is on a Terex Telelec Derrick. As you can see, it shows you fully retracted. Of course, your second stage, your third, with your second retracted, and then your second extended. And of course, on this particular unit, a fourth extended is not applicable. Most digger derricks you'll find it only has 3 stages, so you won't have to worry about the fourth. I think there may be a few on the bigger trucks that have a 4th stage, but on this particular unit it does not. Here's just another example of a different load chart. This one here is on this one's on an Altec digger derrick. Still has the same information on it, it's just a different design. And again, these are found also in your operator's manual of that particular digger derrick. When we start to pick up a load, we need to know what load we're lifting. We need to know how much the lift capacity is of the load chart. We need to know how much the load weighs, and we're going to compare that with the load chart at the angle that we're picking the load up. Keep the load as close to the ground in the vehicle as possible. Lower the loads with the winch, not the boom. So what's the best way to determine load weight? Well, to weigh the load and tag with a current weight, in a lot of cases, anytime you have, say ACSR, for example, a reel of wire, in most places where they carry that wire out, they carry that reel, has a current weight on it, and then when they bring it back in the afternoon, they weigh it again, and that the wire that's been used for that day is deducted from that, so it has a current, so that way we can keep a current weight on that reel. We're going to look at manufacturing label weight. If it's a new reel, the manufacturing label will have the total weight of that particular load that you're picking up should have the weight on it. Now look at the nameplate located on the load. Calculate load using your math skills and a calculator. Those are the different ways we can determine the load. Weight calculations. First, you have to know the terms you'll be using. The first one is circumference. Circumference is the outside perimeter of a circle. Then we have diameter, the line that divides the circle exactly in half. And the radius is half of the diameter. Then we have pi. Of course, you can see it. Pi is shown as the letters PI or the symbol, as you see there on the slide. And pi is it's pretty much it's an irrational number or endless decimal, and it looks similar to the one you see here, 3.14159, and it just continues on, and it goes on forever, it never ends. So if we look at pi, pi is pretty much as you see here. Pi is the relation between the circumference of the circle and the diameter. If we look at the diagram here, the pictures that we see on this slide, basically, in layman's terms, it's how many diameters does it take to get around the complete circle? How many times do we have? It's the length of the diameter, as many times as it takes to make one time around that circle, which makes up the circumference. Some conversions you'll need to know, and this is just something I added in here. Fraction conversions, if you're using a calculator, if you have a quarter, that's going to be equal to 0.25. If you have half, it's equal to 0.50 or 0.5. Of course, 2/3 is equal to 0.666, and of course 3/4 is 0.75. Some more conversions that we need to know about. We're going to be converting length, such as feet. A feet conversion, 1 inch is 0.0833 feet. 3 inches is 0.25 feet. 6 inches is of course 0.5 or 0.50 feet. 9 inches is 0.75. 11 inches is 0.916667 feet. And of course 12 inches equals the foot. Unit weights by pound per cubic foot. 1 cubic foot of steel weighs 480 pounds. All these conversions are going to come in handy when we're trying to determine how much something weighs when we're trying to pick it up with a digger derrick. 1 cubic foot of concrete weighs 150 pounds. 1 cubic foot of lumber weighs 32 to 62 pounds depending on the type of lumber and the type of wood. 1 gallon of water weighs 7.5 pounds. 1/4 inch of steel plate weighs 10 pounds per square foot, and a 1/2 inch steel plate weighs 20 pounds per square foot. Some equations you're going to need: volume of a cube, and we get that by length times width times height. Area of a circle is pi times radius squared. Area of a cylinder, area of a circle times length of the cylinder. And we're going to multiply volume times unit weight, or to get load weight. That's how we're going to end up getting the load weight. All right, so let's look at some of this. We're going to try to keep it fairly simple. If we look at this cylinder, we can see the cylinder 6 foot long, and the radius on the cylinder is 3 feet. So if we take those measurements, we have pi times radius squared equals the area of a circle. Area of a circle times length of the cylinder gives us our volume of that cylinder. So if we apply the area of the circle that we see in the green times the length of the cylinder, which is 6 foot, that gives us the volume of that cylinder. The volume of the cylinder times the unit weight of material that we're trying to pick up is going to give us our total weight. So we take the 3.14, as you can see in the equation below. We have 3 times 3 in parentheses, so we're going to do the multiplication first. Do that first. Once we work this out, if we do the math as we follow the equation, it equals out to 6,358.5 pounds in this particular cylinder. And again, this is a cylinder of concrete. Finding the weight of object you are picking up is important to be able to read the load chart on the trucks before we pick up any load. So we need to know how much an object weighs before we try to pick it up. That way we can compare it to the load chart on the unit. Don't pick up a load without knowing the weight of the load and the maximum load capabilities of the boom at its working position, depending on the angle of the boom. Are you working off the second stage, the third stage? So we need to know all this before we can actually pick up a load. Usually, if you are operating the digger derrick, you'll have another employee there, a coworker there, or that's gonna need to be familiar with some hand signals. And of course, you being the operator of the digger derrick, you need to be familiar with the hand signals as well. It goes without saying, if you're operating a digger derrick, you need to have a spotter. Only one person needs to be the operator of the truck, and only one person needs to be the spotter. We don't need 15 people trying to tell the operator of the digger derrick what he needs to do, because what you're going to end up with is with a digger derrick operator not having a clue what you want him to do or what he needs to do. The spotter and the operator both need to be familiar with hand signals. First one is going to be hoist the load hand signal. This course is with your forearm vertical, forefinger pointed up as you see in the picture. And move your hand in a small horizontal circle. Again, this is hoist the load hand signal. Next we have lower the load hand signal. It's going to be pretty much the opposite. We're gonna with our arm extended downward this time. We're going to have our forefinger pointed down and move the hand in a small horizontal circle. Then we have raise the boom hand signal. Your arm is extended, fingers closed, thumb pointing upward. Lower the boom hand signal is arm extended, fingers closed, thumb pointed down. Extend the boom hand signal, or run your second or third stage out. Both fists in front of the body with thumbs pointing outward. This is for extending your second stage. Retract in your second stage, or retract the boom hand signal. Both fists in front of the body with thumbs pointing toward each other. And of course, move slowly hand signal. Use one hand and give motion, any motion signal. Place the other hand motionless in front of the hand, giving the motion signal. In this particular case, hoist slowly is shown in the diagram above. Raise the boom and lower the load hand signal. With arms extended, thumbs pointed up, flex your fingers and in and out as long as load movement is desired. This hand signal is lower the boom and raise the load hand signal. With arm extended, thumb pointing down, flex your fingers in and out as long as the load movement is desired. And this one, swing hand signal. With the arm extended, point your fingers in the direction of the boom swing. Stop hand signal, of course, is probably one of our most important ones. When something happens, or if we've moved the load to a location where we need it to go. Stop hand signal is with your arm extended, palm down, move your arm back and forth. And of course, last but not least, emergency stop is going to be the same. We're going to have both arms extended, palms down, move your arms back and forth, forward to back. Dog everything down hand signal. This is where we have our clasped hands in front of the body, as you see in the diagram. Of course, when in our digger derrick operation, booms, winch line, or load shall not be brought in contact with or in proximity to an electrically charged conductor to an energized conductor. Also, the operator must not create a connection between the vehicle and the ground. In other words, the operator of the truck needs to stay on the truck. They don't need to step off of the vehicle if they're working in proximity of an energized conductor. Of course, with that being said, that vehicle needs to be properly grounded. Warn all ground personnel prior to lifting the boom from the rest to stay clear of the vehicle and any of its attachments. Place signs, warning lights, and barricades in accordance with company safety regulations and state laws to warn traffic and pedestrians to stay clear of the work area. Make only vertical pulls with the winch line. We don't want to pull anything at an angle. Don't pull from the side. Maintain a minimum of 4 wraps on the winch drum during lifting operations. We don't want to run all the cable out. Of course, when it comes to again winch lines and loads, we'll do not allow riding on the winch line or the load. If equipped, don't exceed the jib capacity load chart. Some digger derricks do not have that. Maintain proper clearance between energized conductors and the boom tip, winch line, hook, and load. Dielectric properties of a synthetic rope are obtained from a new clean rope. I know a lot of times using these on the job site, it's hard to keep them clean, and it's hard to keep them dry, especially in the rain. Winch line hooks shall be equipped with a safety latch. They have to have the safety latch on the hook. If your hook is missing, that safety latch, it needs to be removed from service. Keep winch line wound level and tight don't get the winch line all one to one side on the drum, it will hang up and damage the rope or the cable. And don't forget, call Mississippi 811 before you dig. It is the law. A lot of times when we are doing when we're augering for a pole, digging holes to set poles, or setting anchors with these digger derricks, if we don't call 811 and we damage a facility, damage a utility, say you hit a huge fiber optic for the telephone company, that's going to be an expensive repair. And if you don't make this call to Mississippi 811, those repairs could come out of your pocket. I'm going to raise the boom to clear the clear body and clear all ground personnel. This is when we're trying to lower the auger for the digging operations to auger for holes for the poles. We want to make sure we get that boom up in the air. We want to clear the body and the ground at the same time. That way, if something does happen with the auger cable, if the boom goes to a free swing, we don't have anything in the way of that auger. And of course, we want to make sure when we're trying to unwind the auger that we're maintain a proper clearance from an energized conductor, energized power lines. Don't stand in the auger's path. Use the lower gear only to store and unstore the digger. Do not shift the digger when stored. Don't allow your auger to swing freely. Of course, when we go to dig the auger the hose for the poles, or dig a hole with the auger, we're going to regulate down pressure to get maximum penetration without stalling the unit. If we push down too hard, too much down pressure with the boom, it can stall the truck and the auger will stop. Raise the auger periodically to spin the soil. That will keep the soil from going back down in the hole, and you're constantly having to clean it out. Rocky soil requires slow speed for best results, and keep the auger straight to avoid side pressure. Usually this is another place where your spotter would come in handy. He could see if the auger's straight or if it's crooked, and can tell you to shoot out or suck in with the second stage to kind of keep the auger straight. Dig an auger hose in line with the digger derrick by coordinating the boom down and second stage out. Again, this is where your spotter will come in handy. When we're digging anchors like this, this is for a bust anchor. Dig anchor hose at an angle by coordinating them down, second stage out, and rotation. Again, this is a good chance for your spotter to come in handy. Careful coordination of a digger rotational speed and rate of advance of the boom must be obtained for a slow and steady rate of penetration for optimum installation of these anchors. The digger torque rating must not exceed the screw anchor drive system rating. When we're handling and setting poles, we want to make sure we ground the digger derrick. And when we do that, we want to make sure we pull all of the ground cable off of the truck. Maintain proper clearance from energized conductors and assign a spotter to watch. Again, the spotter will come in handy in this particular situation. Ground personnel must wear suitable gloves, sleeves, and hard hats whenever we're handling poles, especially around energized conductors. Do not allow any uninsulated part of your body to contact the pole, vehicle, or the equipment. Cover the pole with insulating shields and a pole cap if necessary. Cover energized lines with insulating shields, guts, or also known as line hoses. And they can be the rubber or plastic, either one. Avoid direct contact with insulated poles and lines, both. Operator must stay on the vehicle while operating the vehicle. We don't want the operator of the digger derrick to get up and down off the truck. Keep ground personnel clear of the digger derrick vehicle and the vehicle's attachments, just in case the truck becomes energized. Of course, we're handling and setting these poles. We want to know what the weight of that pole is. We're going to review the load chart on the truck. Use a sling to lift the pole. We don't want to use the cable or the rope on the line truck to do that. I know in some cases they in the past crews have they'll use the rope on the line truck and run it around the pole and hook the hook back on the rope. We don't want to do that. Use a sling or to lift the pole. Position the winch line vertically before lifting the pole. Or in this case, you see they're using a choker cable on this pole. Vehicle operation, we're going to stow the boom prior to moving the truck any distance. We don't want to drive the truck or move the truck with the boom uncradled. Whenever we do this, we put an extra strain on areas of the truck where it shouldn't be, because we're going to in order for us to move the truck, we're going to have to pick the outriggers up. Road shocks can cause serious damage. Low wire, trees, bridges can cause broken booms, broken wells, wires, and injuries to any personnel that might still be on the truck. Before we leave the job site, we want to make sure that the boom is properly stored. Outriggers are raised, pads and chocks are stored, barricades and grounding systems are stored and put away. Materials properly stored. Make sure the PTO and the cab switches are turned off. We don't want to be driving down the road with the PTO still engaged. And of course, a final walk around of the vehicle to make sure that everything has been picked up and put where it belongs before we leave the job site. At this point, this is going to conclude the presentation on digger derrick operator training. Normally this is where I would ask for questions. It's kind of hard to do that in this particular setting, but this is going to conclude the presentation. Thank you. Have a good day.